Let's take a look at this question from Larson Calculus, chapter 11.4, question 40. So we're given this little model over here, and then based on that, we're asked to answer a few different parts. There's another one with a graphing calculator, but I'm going to just skip that in this video. So we're given this situation here. We've got A, and then let's call this point over here like C, something like that, so that we can refer to it easier later on. A, C, B, and then this is a right angle over here. There's a force being applied at an angle theta with respect to the, relative to the horizontal. Magnitude 200 pounds of the force, and then AC is 15 inches, BC is 12 inches. So they're asking us in a few, basically what they're asking us to do is optimize and find the maximum force to apply the most torque on this thing over here, right, on the bracket. And so to do that, they've given us a few different parts, and let's just follow those in order and see where we get. So they're asking us to determine the vector AB. There are a few different ways to do that, right, and also the vector F. And then what we're going to end up doing to find the torque is a cross product. So let's begin with F. That's probably easier, right? We want to do this in 3 dimensions. Okay, so that's what we're going to do. We can just say that the first dimension, X is 0, right? We're going to treat this as, so I'm going to draw it out here. This is the y-axis, this is the negative y-axis, and this is the positive z-axis. So this will be the positive y, this will be the negative z. Okay, and then you can imagine X is coming off the screen towards you like that, and nothing is happening in that dimension, so we're just going to keep that at 0 over here. But this is like the scheme that we're going to be using. Anyway, if that's 0, what is the y component going to be? Well, it's 200. It's just going to be this part over here, so that's 200 cosine theta. And is it going to be positive or negative? Theta is, first of all, theta is an acute angle, obviously. So cosine of theta, which is an acute angle, is going to be positive, but we need it to be negative, so we're just going to put a negative sign in front. And then for the z component, it's again downwards, so that's going to be negative. So it's going to be negative 200 sine theta. Okay, so it's a little bit messy. I'm going to shrink the kind of reduce the thickness if I can, so that it looks a little better. I don't know if I can do any more. Anyway, that's F. Now we need to do it with AB, right? So AB, again, based on this, there is no movement in this direction of the screen, right? In the Z direction, so in the X direction, so that's going to be 0. It's leftwards 15 inches. They don't really specify units here, so we're just going to stick with inches then. Later, of course, we can't divide everything by 12 to get to feet. And then over here, it's going to be positive 12. The reason for that is because you're going up by 12, right? Up is a positive Z direction. Okay, so we're done with this first thing. Right, we found F, we found AB, so this is part A. Let's move on to part D. We want to just evaluate AB times AB cross F. So let's write that down. To do this, we need to set up a little matrix, right? So the top row is going to be the unit vectors I, J, and K. Now it's AB cross F. So we'll do AB first, right? Negative 0, negative 15, and 12. Over here we have 0. We have negative 200 cosine theta. And then negative 200 sine theta. Looks a little messy right now, but we'll be fine. Actually, one way to know that we'll be fine is that when you take any of the, I don't know if it's minors or cofactors, but basically, so the first part of the determinant is I. You cross this out, and then you find the determinant of this matrix over here, multiply that by I. When you do that for any of the other variables, like J, look at this, you're going to have a 0 and a 0, so that entire section is going to be like nullified. Same thing with the K. So the only thing you need to worry about is the I. Okay, so let's go ahead and do that. We're going to get I times negative 15 times negative 200 sine theta. That's just going to be 300 sine theta. Then we have minus, this is 240. Wait, sorry, it's minus, and then we have a negative 200. So negative 240 cosine theta. And lucky for us, this simplifies out nicely. Again, yeah, if you want, you can go through the process, but you'll see that the J components and K components of the cross product will just be 0. So there's nothing to worry about over there. This, on the other hand, is also nothing to worry about. It's 300 sine theta plus 240 cosine theta. we can take out like what, 60 from this, I think. So we get 60i times 5 sine theta plus 4 cosine theta. Okay, I think that's sufficient for part B. Right, find the magnitude of the moment. And now for part C, we just need to plug in theta equals 30. Right, that's not too difficult at all. 60i times 5, sine of 30 degrees is 1/2. This will be 4 times root 3 over 2. So that's 60. Well, no, let's make that 30i times, over here it's now 5 plus 4 root 3. And the units for this will be, they'll be lb, pounds, inches. And this is part C. Now let's move on to part D, which is where we're going to be essentially optimizing it to find the maximum possible magnitude. The 60 is a constant, so what we want to do now, I'm going to just bring this out over here. You want to take the derivative and equate that with 0 to find the ideal angle to optimize it, right? So 5 sine theta plus 4 cosine theta. The derivative of that with respect to theta is 0. And now we just need to solve for theta. So let me make this a little neater first so you can actually read what I'm doing. Doing this, we're going to get 5 cosine theta minus 4 sine theta equals 0. Hopefully you know how to solve this. There are a few different ways. One of them includes squaring both sides, but that's pretty dumb when you can just do this instead. Right, 4 sine theta. Now you divide both sides by 4 cosine theta, and that's going to give you 5 over 4 equals tan theta. So theta would equal the inverse tan or arctan of 5 over 4. Just with that, we're done now. Let's go up and take a look at the question and see if that makes sense. This slope over here is negative 4/5. Negative 4/5. So this slope over here, which is 5/4, is its negative reciprocal, meaning these two are perpendicular, and that is indeed something that would make sense. You'd probably expect that to maximize the torque. So yeah, it makes sense. It's arctan of 5 over 4. And with that, we're done with all these parts. I think the last part of the question was something like graph it for different values of theta, like using a graphing calculator, and then see what you notice over there. But we've answered like all the significant parts over here. So hopefully you learned something new. Hopefully you enjoyed this question, and I'll see you in the next video.